All right, this lesson is on graphing functions on the coordinate plane. So remember last time we talked about the coordinate plane, it's our xy axis, and it is used to graph functions. So we have a function here, it's our y equals 2x plus 1. And all it means is that we can input values for x, so put numbers in for x, and we'll get out values for y, so like an input-output. So first we want to decide what numbers to plug in. You don't have to get crazy and put things like 100 and whatever, start basic. I'm going to put in 0, 1, and 2, okay? So when I plug in 0, it would be 2 times 0 plus 1. So when I plug in 2 times 0 plus 1, and let me move this and put this up right next to it, y is going to equal 1, right? Because 2 times 0 is 0, plus 1 is 1. The next one, when I plug in 1, it'd be 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3. And then 2 times 2 plus 1, and I get 5. All right, so that's our table, plugging in some values. And you can go on forever, right? There's infinite x's, and for each x, there will be a y that you would get. And so these are all coordinates now. Remember, coordinates come in the format x, y. So this first one is 0, 1. Okay, so I'm going to go plot 0, 1. So I don't go anywhere on the x-axis. It's at 0, but I go up 1 on the y-axis. My next point, 1, 3. I'm going to go to 1, 3. And my final point I have is 2, 5. 2, 5. Okay? So I plotted my points, and now I'm going to play a little connect the dots and connect them. Now, notice what I've done with my line. I didn't just do the line from here to here where the dots are. I let it keep going because remember, there's infinite possible x's I could have plugged in. I could have plugged in 100. It wouldn't have made sense because I'd get 201, but you can plug that in. So that's why these arrows are on the ends, because this line goes on forever. This line, this blue line, represents this function. Okay, they are the same thing as each other. This function is that line, and that function goes on forever in both directions, okay? This is what's called a linear equation. You'll notice it up here, it says linear, and you might guess why. It's because it's a line, right? So this sort of equation graphs as a line. It's a line that goes on forever. Your goal is to find some points to basically uncover that line, okay? Now, obviously, to make a line, the minimum number of points you need is 2 points. So in theory, we could do this just finding 2 points. But there's a reason we end up doing 3 points. The reason I do 3 points is to avoid making mistakes. Okay, so let me show you what might have happened otherwise. Let me erase our correct line and show you what you might have done accidentally. Let's say you're graphing it, and 0, 1, a lot of people mess up graphing that coordinate 0, 1. Okay, sometimes they accidentally do 1, 0, and they put it over here. All right, so if you accidentally did that, and then you go to graph 1, 3, if you only have 2 points, that still makes a line, right? It's the wrong line, but it makes a line. I can connect them like that, and it would be a line, okay? Let me delete that and show you. Now, if I have my third point of 2, 5, now when I go to connect it, I realize this does not make a straight line. I start doing this, and then I have to also curve and go this. That's not a straight line. So this is clearly wrong. Okay, so the reason we do 3 points and not just 2 is 3 points let us know if we made a mistake somewhere. If it doesn't make a straight line, something is wrong. Okay, if you just do 2 points, you'll make a mistake and you'll have no idea because 2 points will always make a line. Okay, so that's why we're going to do 3 points for all our linear equations when we're graphing them. All right, so on this one, notice it says f of x. That's just another way you'll see it. It means the same thing as y. You can rewrite it as a y if it really bothers you. People get thrown off because they think of these parentheses as multiplying the variable f times x, which makes sense because it does mean that a lot of times, but in this case it doesn't. It just means the function of x. So f of x, function of x. So I just want to show you that because you'll see that a lot of times too. But feel free to write a y there instead, no problem, okay? All right, if you think you understand how this whole graphing thing works, go ahead and do it on your own. If you need to watch step by step, just go ahead and keep watching. So pick some numbers again. Go a little crazy, we'll go -1, 0, and +1. All right, so negative 1 would be negative 4 times negative 1 plus 2. So that would be a positive 4 plus 2, which is 6. 0 is always the easiest because when you multiply, it makes the negative 4 coefficient go away. So it ends up just being 2. And then my last one, negative 4 times 1 plus 2. So negative 4 times 1 is negative 4 plus 2 is negative 2. All right, so I have my 3 points. So my first one is negative 1, 6. Because remember, f of x, like I said, same thing as y. So here's our xy coordinates, right? xy, xy, xy. All right, so negative 1, 6 would be up here. 0, 2 would be right here. 1, negative 2 would be right here. And I connect my dots, and look, they make a straight line, so I didn't screw up or make a mistake. So as long as you connect to a straight line, you know it's right because this is a linear equation. F of x equals negative 4x plus 2 graphs as that blue line. It goes on forever because there are other numbers you could have picked. If you do this on your own, you may have picked different numbers than I did, but your graph should still look the same. It's just you'll have different points marked on the line, but you'll have the same line as me, okay? All right, go ahead and pause it. Try this one on your own and hit play to check your work. All right, this one, when you're picking your numbers, you want to be careful what you pick because it's a fraction. If I pick 1, 1/3 times 1 is a third. A third minus 7, that's really annoying. So I'm not going to pick 1, okay? What you want to pick is numbers. 0 is a really good number because they'll make the third completely go away. And other numbers you want to pick are all multiples of that denominator. And you'll see why, because they'll end up canceling out. So what I'm going to pick is negative 3 and positive 3. Let me show you why. So I start doing my math. I go 1/3 times negative 3. I'm going to put negative 3 over 1 minus 7. So look what happens. These 3's cancel out to a negative 1. Okay, so then it's negative 1 plus negative 7, negative 8. So by using a multiple of that denominator, I got it so that my y isn't a fraction. You want to avoid those fractions because that makes it very annoying to deal with, okay? 0 is always a great choice because 1/3 times 0 is just 0. So then it's just negative 7. And then 1/3 times 3 over 1. The 3's cancel out, so all of that's 1. Plus negative 7 would be negative 6. Okay, so think carefully. If you have a fraction, you always want to pick your numbers as multiples of that denominator. And then 0 is a good choice no matter what. 0 should always be one of your choices as far as what numbers you pick. All right, so let's graph our points. We got negative 3, negative 8. We have 0, negative 7. And we have 3, negative 6. So our line's right down here on the bottom going on forever. So make sure your line that you're extending it all the way as far as you can with arrows on either end showing that this linear equation goes on forever. There's infinite x's you can plug in and each one would have a y. Okay? All right, so let's try this one. We got y equals x squared plus 1. So in this one, it doesn't really matter which numbers you pick. It's not like the fraction one where there's numbers that are annoying. So I'm just going to pick negative 1, 0, and 1. All right, so we got negative 1 squared plus 1. So negative 1 times negative 1 is just 1, right? Positive, the negatives will cancel out. Plus another 1 is 2. This one's 0 squared plus 1. Well, 0 squared is 0, plus 1 is 1. And this one, 1 squared plus 1. 1 squared is 1 plus 1 is also 2. Okay, so look what's happening here. We got negative 1, 2. We got 0, 1. And we got 1, 2. So this is not a line. And you might be like, oh no, we did something wrong. But this is okay. This is a different kind of equation, okay? This is actually not linear. This is called nonlinear. So if there is an exponent, as there is here, so any equation with an exponent, okay, so something like this, will graph not as a line, but as a U. Graph as a U, okay? So if we look at this graph here, the way it's going to look like this, okay? And the bottom of my U is right there, that's 0, okay? So you just memorize that, know that that's okay. You notice the previous ones we've done, if we backtrack a little, none of these had exponents, right? So they were all linear equations. They graphed as lines, just normal old equations. But as soon as you get an exponent in there, your equation will graph as a U. Know that it will graph as a U and look for that U shape. And it's a nonlinear equation. There's another kind of nonlinear equation we're going to talk about. So again, this is nonlinear. And that's when it has absolute value bars, okay? So again, this is not going to be a line. Let's figure out what shape it is going to be, though. So I'm going to do -1, 0, and 1 again. So this one is absolute value of 3 times -1. So 3 times -1 is -3. But the absolute value, remember, is always positive, so that would just be 3. This one, 3 times 0 is 0, and the absolute value of 0 is still 0. And then 3 times 1 is 3. Absolute value again, 3. Okay. So this one we have 0, 0. We have -1, 3, and we have 1, 3. Now this looks like it could also be a U, but it's not. It's close to it. It ends up being a V. Okay. And these are just things you just want to memorize. So anytime an equation has absolute value around your x, so equation has absolute value around the x, it graphs as a V. So those are the 3 types of equations that you need to be prepared to graph. We will most often graph linear equations, okay? So most of our equations will be linear. It's just regular old equations where it's just normal x multiplied by some number, adding to subtracting by some number, and it's linear, it's a line. The 2 nonlinear equations we will work with is if the if the variable has an exponent, and the other ones we'll do a squared. So if it's x squared, it will be a U. And if it's absolute value around the x, it's a V. Okay. So let's talk for a second about why this is. Okay. So the absolute value one's an easier one to realize. Okay. So if the absolute value bars weren't there, then this first one up here would have been a -3. That would have been negative, okay? So instead of this point up here, I'll make it green, instead of that point being there, it would have been down here. And this would have been a straight line, right? It would have gone straight through like that. But as soon as you put the absolute value bars around it, you cannot have anything that's down in the negatives. Nothing down here, okay? You can't have anything down there because any negative becomes positive. So you notice what happens is this part of the line right here flips and becomes this part of the line up here. Okay, so that's what's happening with the absolute value. That's why it's a V, because basically it would have been a linear equation, but when you put the absolute value bars around it, any negative answers get flipped up and it becomes a positive, so it looks like a V. Okay. Now it's a similar idea for the exponent one that becomes a U, but slightly different because it is a U. So it was never going to be a line, okay? So first of all, the exponent does make it so there's no negatives, right? You see right here, this was a negative number, but when you square it, -1 times -1, the negatives canceled out. So that is keeping it from going down here, okay? So that's part one of why it goes back up. But the reason it's a shape of a U and it's not a V is because it goes up exponentially. It's exponents, right? So if I square the number 1, I still get 1. But if I square the number 2, I'm all the way up at 4 already, adding 5, okay? If I square the number 10, so if I put in 10 for x, that's 100. So it's going to be all the way up there at 101. Okay, so the equation is moving up very, very quickly, faster for the y's than the x's, because every x you put in is being squared and it's going up much quicker. Okay. All right, so we've talked about linear equations versus nonlinear equations. They will graph as a line. And nonlinear equations, if they're exponents, they will graph as a U. And if they have absolute value bars, they will graph as a V. So just looking at these, you can see which would go with which. Okay.